Welcome back. So, we are talking about probability. We have wrapped up some of the basics. We've talked about experiments, outcomes, we've talked about sample spaces. We've built up our simple probability equation where we have number of desired outcomes divided by total number of outcomes, where all those have to be equally likely or the equation don't work for us. And we've talked a little bit about independent events. We'll move more into that a little later when we get down to some of these miscellaneous topics. For now, though, let's get into mathematical expectation. And what we'll see here is how to deal with the value of, well, for lack of a better term, gambling. Probability, and this is going to shock maybe some of you, is heavily rooted in gambling. A lot of the great mathematicians who forwarded and even founded, to begin with, the idea of probability and probabilistic analysis all started because those self-same people were gambling addicts and were really bad at gambling. And so a lot of the work that started the whole discussion on probability theory was how to get good at gambling. So we'll have plenty of examples about that just because we cannot divorce ourselves from gambling. It's heavily rooted in it, but it has plenty of applications beyond that as well. All right. In this unit, we will start and hopefully end asking and answering the question of, is it worth it to go for this risk? Expected value is a very good tool in risk aversion, in risk analysis, in determining if something is worth the risk. So expected value is a very simple calculation. You've got some outcome and the probability of getting that outcome. You multiply those two together, you have the expectation for that outcome. You add up the expectation for all of your different outcomes, you've got expected value. That's really it. Outcome times probability. Outcome times probability. Outcome times probability. That's all you have to do. And in the next video, maybe two, we will really work a very important example. A lot of people love gambling. It's addictive, it's fun, but not, as we'll see, financially feasible in the long run. So we'll talk in this video about one of the most popular ways of gambling, which is the lottery. What I've pulled up here for you is the table of payouts, and this is taken from the Wikipedia for the Powerball. This is Powerball. There are 5 numbers that are drawn out of a pot of 69, and another red number called the Powerball, which is drawn out of a pot of 26. Now, if we had more time this semester, we would actually calculate these, but I'll go ahead and give it to you. The probability of getting just the Powerball is, strictly speaking, should be about 1 in 26. I don't know exactly where this came from now that I think about it. I'm sorry, I know why. It's because it's also got these in here as well. So altogether, these combine to be 1 in 26. Then these other things, we'll worry about those in another semester. But altogether, we get this many different ways of getting at some money if you play the Powerball. Actually, we will calculate this last number here. We'll see that one. So those are your different probabilities, and here are your different outcomes. So to do expected value, all you have to do is take for each outcome times probability. So it's going to be $4 times 1 over 38.32. $4 times 1 over 91.98. $7 times 1 over 701. And you just run this down all the way through. And let's see here, the numbers check out. Of course, I don't have a probability here, but it's for an outcome of $0. So 0 times whatever is still $0. And that gives me my expectation per outcome. 10 cents, 4 cents, 1 cent, 1 cent. Effectively nothing. 1 cent, 9 cents, 34 cents. You add all those together, you're looking at an expected value of 62 cents if you play, but it costs you $2 to play. See you in the next video.